We're going to be looking at exponents of 0, 1, and any negative exponents and learn the rules for those. The first one is anything to the 0 power is always going to be 1, unless the base is 0, because 0 times anything is going to be 0, so that's different. 0 to anything is going to be 0. So it could be 3 to the 0 will be 1. It could be negative 2 to the 0 is still 1. It could be 10 to the 0 is 1. It could be a crazy number like 9,762 to the 0 is still going to be 1. Or just 1 to the first is going to be 1. And then we look at anything to the first power. So y represents any number to the first power is always going to be just that number again. So an example would be if I have 5 to the first power is going to be 5. Where it gets a little bit tricky is when we have negative exponents. So here's where it's showing us what to do with negative exponents. A variable or a number like x to the negative exponent, some number, is equivalent to taking the reciprocal of that. Remember, reciprocal means when you are flipping a fraction upside down. So I can think of this first one as a fraction, x to the negative 8 over 1, and then we flip that upside down so the 1 goes to the top, the x goes to the bottom. But notice that the variable was negative, the exponent was negative, but now the exponent is positive. So when you take the reciprocal of a problem with a negative exponent, it makes that exponent positive. An example would be if we have 5 to the negative 2. So again, we think of that as a fraction. I can put it over 1 to make it a fraction. And then I'm going to take the reciprocal of that. So I'm going to flip it upside down so the 1 goes onto the top, the 5 goes onto the bottom, and now the exponent becomes positive. But for a warning, we're only flip negative exponents. So we will get to some problems that have multiple exponents involved. We only want to flip the ones with negative exponents. Now let's look at some examples. So let's start out with some examples of the negative. We're going to think of this one as a fraction, so over 1, and then we want to flip it upside down, 1 over, and x goes on the bottom. But when I flip it, take the reciprocal, it's going to make that exponent positive. Number 2, well, the exponent's already in the bottom, but we can still take the reciprocal. So I'm still going to take the reciprocal. That makes the m go to the top. And remember, when we take the reciprocal, it makes that exponent positive. That's the whole reason why we take the reciprocal, to make it positive. And the 1 goes to the bottom. So it doesn't matter where that exponent is at. If you take the reciprocal, flip it, it will make it positive. Number 3 is an example where we're only going to flip what has a negative exponent. So if we look at this carefully, just the x has a negative exponent, not the 3. So when I'm going to think of this as a fraction, but when I flip it, the 3 does not have a negative exponent. So the 3 is going to stay on the top of that fraction where it's at. But the x then is going to go down, flip. So the x was on top, it's going to go down the bottom to become positive. Now I could flip that 1 up to the top and put that 1 here. But if I multiply 3 times 1, it's still going to stay 3. So that wouldn't change that at all. So we really only need to put the 1 on top, like we did over here in number 1, because I have to have a number on the top. And if I didn't write the 1 there, there'd be nothing there. But on number 3, we already have a number there, so I don't need the 1 for a placeholder. Okay, so similar on number 4, it's already a fraction, so I don't have to do that. But the 7 does not have a negative exponent, so it's going to stay in the numerator where it's at. But the x does have a negative. So to make it positive, we're going to take the reciprocal, flip that. Just flip what has the negative. That's going to go to the top to be positive, and then there's nothing left on the bottom. So I could put a 1 for a placeholder, but if I divide by 1, that's not going to change anything. So really, I don't have to have a denominator then. If all that's left on the bottom is a 1, then we don't have to have that denominator at all. Number 5, we're going to think of this as a fraction, and we are only going to move what has a negative exponent. So the 8 does not have a negative exponent. It can stay in the numerator where it's at. The x does have a negative, so it will move down, and when I move it, it becomes positive. The y also has a negative, so it's going to move. It's going to go down and make it positive. Remember, when you move it, it changes it to positive. Number 6, it's already a fraction. The x has a negative, so it needs to switch. The x is on top now, so it needs to go to the bottom to make it positive. Then I look at the y. The y is already in the bottom with a negative. So since it's already in the bottom, I move it up to the top, and when I switch it, it makes it positive. Okay, so that was rewriting with just positive exponents. Now we're going to look at actually evaluate, which means we're going to solve the expression. So first, let's think of this as a positive exponent. So think of this as over 1. We're going to move this down to the bottom to make it positive. I can't have nothing on the top, so I'm going to have that 1 for a placeholder. And this means 1 over, 3 to the third means 3 times 3 times 3. So that would be 1 over, 3 times 3 is 9, times 3 is 27. So 3 to the negative 3 is 1 over 27. On number 8, it's already in the bottom, so I'd have to move it to the top to be positive. There's nothing on the bottom. I could put the 1, or I don't need to. I can just leave it as 2 to the 5th, because anything divided by 1 is going to stay the same. So this means I've got 5 2's. 2 times 2 is 4. And 4 times 2 is 8. 8 times 2 is 16. And 16 times 2, that's going to give us 32. Number 9. The 3 does not have a negative exponent, so it's going to stay where it's at. The 5 does, and it's in the bottom, so it needs to come up to the top. And when I do that, it's going to become positive. Now I've got these two things up here, so we have to know that that means we're multiplying. So when we move to the top, we have two things up there where they're being multiplied. And then I have nothing left on the bottom. I could put a 1, or I can just get rid of that. So now I'm going to go ahead and do the 5 squared first. So 5 squared is 25, so that's 3 times 25. And then 3 times 25 is 75. So the negative exponents are definitely the harder part. We're going to just move what has the negative. If it's up, move it down. If it's down, move it up. Then with a quick review of our other rules. Anything to the 0 power is going to be 1. Anything to the first power is going to be itself, so 7. Number 12 is a little tricky. Number 12, we have to remember that if we look at this one, it is just the 4 that has the exponent, not the negative, so the negative comes down. 4 to the 1, that's just going to be 4. So our answer is negative 4. And number 13, our last one, again, anything to the 0 power is just going to be 1.